All right, welcome to the disaster area that is my workbench. I haven't made a video for quite a long time, but mainly because I've been working on things. So I went and decided to come up with a GPS module or device that will provide the RTCM with all that it needs to simulcast easily. And that would be this guy right here. This is version 2.0 of the module. It's actually 2.04. The first one I made only provided 9.6 megahertz, the NEMA data from the GPS, and 1 pulse per second. And I had people request that, well, can't it have the reference for the transmitter? And I said, sure. So I went through another few designs. So this module you see here, it has a GPS board in it for the GPS antenna with an SMB connector. And it gives you out the front the NEMA data in an RS-232 level, 1 pulse per second, and 2 RF outputs. This is the synthesizer that I'm using. This is based off of the Prog Rock 2, which is a GPS disciplinable synthesizer based off the Silicon Labs 5351A chip. So the 2 RF outputs are programmable up to 100 megahertz, and they're limited by the low-pass filters that are in them. As you go up in frequency, the level begins to drop off. So, but you can program these outputs to whatever you want them to be. This one right now is actually programmed for 9.6 on the second output and 14.4 on the first output, because I'm going to be putting this in as a replacement at my one site, which uses a modified MaxTrack as a transmitter. But if you're using something that used, say, 16.8 for a reference, or 12.8 for a reference, or 10 megahertz for a reference, you could use this. And this would provide the RTCM with everything it needs, as well as the reference for your simulcast transmitter. This is the circuit board that is for this particular one. There's actually a slightly different model that I'm going to be using a board of this, but it's going to pretty much look like this. I think this is the version 2.0, but I have a 2.04 that's coming out. Then I made some changes and I corrected a few mistakes that I made on this board itself. So these boards I had made by PCBWay. So good quality boards, and it works well. So some of the magic in this is done by a U-Blox GPS module board. These boards, you can get them rather inexpensively on eBay from the surplus market. Depending on the model, you can get them for as low as $7, $8 a piece. So, and that's what is the GPS receiver that's inside this box. So, as you can see, it's sticking out the back here. So yeah, I'm going to be putting this up for testing. I have one of these testing at one of my main sites, and it's been, worked fantastically well. And this is going to be put at my other site with my MaxTrack to just check it out using 14.4 as a reference out of this. So, but I designed it to fit in a nice Hammond box. The front and back plates that I made are made of PCB, and it's reasonably RF tight. So, and doesn't produce any harmful harmonics outside of it that cause problems. So that is it. The first ones that I made actually looked like this. So these would only produce a 1 pulse per second, the NEMA data, and the 9.6. And the 9.6 was actually derived out of the synthesizer of the U-Blox LEA M8T, because this has 2 time pulse outputs. So one time pulse output would be set to 1 pulse per second, and the other time pulse output would be set to 9.6 megahertz. So, but with the upgraded version, we have far more flexibility when it comes to the frequencies. So, I don't know why this doesn't want to focus, but so yeah, after I'm done going through my testing, I'm actually gonna probably offer these for sale for anybody who wants them, so that simulcast will be much easier. So, I just wanted to make a video on that update, and hopefully the testing goes well. And I'll announce a price for these once I feel that they're up to my standard, and so that anybody can get a hold of them. So it reduces the amount of equipment that you need, and it makes a pretty flexible piece of equipment. So, which can be used for other things as well, not just the RTCM, but that's originally what it's designed for. The NEMA, or the serial data on this, is directly connected to the U-Blox GPS receiver, so you can actually manage and configure the GPS receiver through this connector. And it's wired the same way as the BG7 TBL units are wired. So if you have a BG7 TBL GPS discipline oscillator in service, you can swap it out directly with the DB9 connector, because it's wired exactly the same way. So I will hopefully be posting a video of doing a drive test with this in the near future, and listening to the simulcast overlap, and we'll go from there. Have a good day.